Welcome to Module 2 of Programming in C. I'm your professor, Professor Fiske, and like I've said in all my other videos, if you haven't done so already, please like and subscribe. It helps me with the content to know what is relevant, what you're interested in looking at and learning more about. So in this micro lecture, we're going to discuss jump statements. Now, we've spoken about jump statements in passing in the last two lectures, but I want to talk about jump statements and how important they really are. So, what are jump statements? Well, jump statements allow us to manipulate where we are in our stack trace. Our stack trace is determined by the number or the level that we are numerically going down the stack when the program fires line by line. Well, in this for loop, basically what we made this for loop do is take the, and I'm going to erase all of this real quick. Take the input John, and I'm actually going to put that back. Take the input of John, and I want you to loop over it and print each of those characters one by one. But let's say I don't want to print a specific character. Well, what I can do is I can say if I equals 3, right? Then I don't want you, no, if I doesn't equal 3, I should say, then don't print. And what would happen? Well, I would get J-O-N or J-O-H. I don't want that. I want 2. There we go. J-O-N. Bam. John. Okay? It didn't print the H. But this is a lot of development. I actually want exit conditions and I want happy paths. This doesn't do that for me. And what it does is it makes the code really hard to update and refactor later on down the road. So what I really want to do is I want my happy path to always be my happy path. And I never want to change that. And what I want to do is I want to create unhappy paths that I can do something with in the event I want to skip them or I want to stop the loop entirely. So if I is less than or equal to 2, then what I want you to do is continue. Now, in another class, we talked about break, right? Remember break? What does break do? Well, break stops the loop entirely, right? And it was in 2 lectures ago, we talked about using the word break, or the reserved word, the jump statement break, in a do while and a while loop. If you want to know more about break, go back to that micro lecture. But that is a jump statement as well. I want to talk about continue because this is the often used jump statement as well. We use jump statements in loops because there are certain situations where a criteria is met and we don't want the code beneath that criteria to fire. We do not want this to print in the event that this is reached. So I put continue here. But what does continue actually mean? So the word break, the reserved word or jump statement break, means don't run this loop anymore. Stop the loop entirely and don't loop anymore. We're done. Go to the last place of the loop, the last curly brace in the loop, and run stuff after that, right? In this case, what does continue mean? Well, it does stop things, just like the break statement does. But what continue actually does as a jump statement, what continue does is it stops the iteration. All right, so what's happening in the second iteration? We're trying to print the letter that's there, right? Well, what if I don't want this to print? Well, continue will tell the program, it will tell the application, it will tell the computer, I want you to skip all of these lines, and if there is another loop or another iteration after this one, go back to the top and determine what needs to happen next. That's what continue means. And just like we did when we had our happy path sitting inside this expression, our happy path never needs to be modified. We can code for our exit conditions. This is actually an exit condition, not an unhappy path, sorry. This is an exit condition that we're pulling out of our code. So if I ran this, I would get the same outcome if I is not equal to 2, if I equals 2, sorry. There we go, John. I had it backwards, so it only printed the second position, but I want to print everything but the second position. Remember, 1 equal sign means equality. 2 equal signs mean, you got it, assignment. I am very annoying, and I will continue to iterate over this like a loop until it hits you in the face, and it's a part of you, all right? So, this is my exit condition for continue. If I said break here, what would actually happen is it would only print Joe because it broke the whole loop and it left. What does that look like in our debugger? Well, let's take a second to go look at that, and then we will pivot away from this topic. So if I ran this, what will happen is it'll come down to line 6. It should have came down to line 6, actually. It didn't. It'll come down to line 8 and stop. It'll come down to line 8 and stop. It's not stopping. All right, let's do this. Let's go above the loop. Oh, it's because I'm running it. Ah, you guys let me do that. Debug. Fantastic. So here we are. I equals 2. What is I? Well, I at the moment is 0. This is our first iteration. It's our 0th iteration. So we have a ways to go. I actually want this on the right side. Change tab. Yeah. I want you. Yeah, change tabs. What I was trying to tell you to do. There. I want you over there. Perfect. Okay. So we're in the for loop. I equals 0. So here we go. Now we're checking. Well, I really does equal 0, so this is not true. So it's not going to continue. And it's going to print. What is it going to print? It's going to print what's at the 0th position in the input. The input has the characters J, O, H, and N. And if I click this down here, you can see it. J, O, H, N, nothing. Right? These are all the characters that are sitting in the character array or in the string John. So what's going to print in this specific iteration? Well, whatever's at the 0th location, which is the letter J, which is represented by the ASCII 2 symbol, or J, which is represented by the ASCII 2 hexadecimal binary of 74. So this will print. We have J at the bottom. We go back to the top and look at this. I is 0 because the iterator hasn't fired yet. The iterator should fire. Now I is 1. We're in the second iteration of the loop. All right. Notice I is 1. I is 1, so this is not true, so continue will not fire. It'll go down and it'll print again whatever is at the first position in the array of John. So what's at the first position of the array of John? The 0. So that's what's going to print, 0. We still haven't made it. We're now in the second or the third iteration, right? And the third iteration is 2. Okay, great. So this is going to be true. What's going to happen? It's going to go into the if statement and skip everything after it and go back to the top of the loop and try the heck again. Great. Well, let's try this. What happens when we break? And we're going to go a little faster through this one so you can see. So here we go. We're in. There we go. We're in. We're at the 0th position. I is 0. I is 0. There we go. I is 0. Good. So we're going to print J. I is 1. We're going to print O. But what happens now? I is 2. This is true, right? This expression is going to be true. So when it breaks, what does that actually do? Well, it leaves the loop. It completely breaks the loop and it won't run that loop anymore. Those are the two most important jump statements you will ever use. There's another jump statement that we use a lot as well, but I haven't seen it nearly as much as continue and break, and that's go to without a space. I'm not going to speak about go to because I've maybe used it once in the last 20 years. Continue and break are your go to. You like that pun? They're your go to jump statements. Great. Fantastic. Now, when can I use a break and when can I use a continue? Well, you would use a break and a continue in loops. Normal iterative statements. There's another type of loop that I don't talk about because it's not a real iterative statement. It is a jerry-rigged iterative statement, and that's called recursion. And we'll talk about recursion and recursive loops when we get to functions. Well, as I said in the beginning, please like and subscribe. It helps tremendously. And if you're having a good time, continue to have a good time. Keep watching. There's more to follow. And as I say in all my videos, good luck. Have fun. Ciao.